Let me ask you something. You've spent months building out your AI infrastructure. You've got the GPUs, you've got the model. You've done everything right. So why is it still slow? Here's what I've learned after almost 10 years working as a solution architect at a hyperscaler. 9 times out of 10, the problem isn't your model. It's not even the compute. It's what happens before any of that ever even kicks in. It's your data pipeline. That's where most people never look. And most teams don't even realize that's the issue until they're already in production. Then they're wondering, why is everything falling apart? That's what we're getting into today. The real reason AI underperforms at scale and what it actually takes to fix it. Quick note before we dive in. This video is sponsored by F5. They're the company behind the infrastructure technology we're going to talk about today. This is a topic I'm excited to talk about because I see this tripping up teams all the time. Okay, so here's the thing. When most people think about AI performance, they go straight into the model. Is it big enough? Is it trained well? Is the hardware fast enough? And sure, all of that does matter. But here's how I think about it. Picture a Formula One race car. Now that's insanely powerful. It's built to go fast, but if the pit crew can't even get fuel to it fast enough, what good does it do it? That car is going nowhere. Your GPUs, they're that race car. Your data is the fuel, and your data pipeline is the pit crew. If that data pipeline can't keep up with your GPUs, they just sit there idle, burning money, doing absolutely nothing useful. So what actually breaks in that pipeline? I've seen it come down to 3 things every single time. The first is latency. In AI workloads, you're not making one request for data. You're typically making millions simultaneously, and any delay in that flow compounds fast. Second, throughput. AI data ingestion is bursty and heavy. Parallel writes, massive file transfers, multi-part uploads, all happening at the same time. And when you think of that legacy network infrastructure, that was never built to handle all of that. It just chokes. And the third thing, reliability. Storage nodes going down, clusters needing to rebalance, maintenance happens. And when any of that interrupts your data flow, your training job doesn't just slow down a little bit, it can fail completely, and you're starting over from scratch. Here's what makes this frustrating. In that dev environment, everything looks fine. You have small data sets, a handful of requests, and everything runs smooth. You push to production, the data volumes start getting real, and suddenly the whole thing falls apart. Now that's when the team realizes they've got a problem in that pipeline, not a model problem. Most enterprises running AI today are running it on S3 compatible object storage. Your training data, your fine-tuning data sets, and your retrieval augmented generation indexes, all of it is sitting there waiting to be delivered to your GPU. And between that storage and those GPUs, there lies the network layer. Now that's where the gap starts. Organizations there are completely exposed. Without something sitting in that layer managing that traffic intelligently, one slow storage node backs up everything, and the requests start to pile up, and a node starts to go down, and those jobs start failing. Your GPU utilization tanks. It's a real problem, and it's more common than people want to admit. So what's the fix? What that network layer needs is actually something that can actually manage the data traffic intelligently. Load balancing across those storage nodes, automatic failover when something goes wrong, traffic shaping so your most critical workloads always get what they need, and real-time visibility into what's happening across the whole pipeline. This is what's called Application Delivery Controller, or ADC as abbreviated. It's a category of technology that's been solving this problem in web and application delivery for years. The insight is that the AI data pipelines have the same fundamental challenge, just at a much bigger scale. When you add an ADC into your AI data path, here's what changes. Now that load balancing means no more single storage node that can fail and become a choke point. Automatic failover means if a node goes down, the traffic reroutes automatically, and your job keeps running. Traffic shaping means your high priority workloads get the bandwidth they need without fighting everything else. And you get visibility into the whole pipeline in real time so you can actually see what's happening instead of guessing. This is exactly what F5 Big IP does in the AI infrastructure space. It sits in that delivery layer, keeps that data moving at the speed and volume your data workloads demand, making sure those GPUs are actually earning their keep. For any organization running AI at real scale, this layer is not optional anymore. It can be the difference between your AI application delivering and one that just burns through your budget. If you're responsible for your AI infrastructure in any way, whether you're building it, running it, or making decisions about it, make sure you take a closer look at that data pipeline that we talked about today. It's where you need to put your focus and attention to right now. I'm dropping a link in the description below so you can check it out. And if this was helpful, make sure you subscribe. I put out content like this regularly because this is the stuff that actually matters when you're trying to make AI work in the real world. Drop a comment too. I'd love to know what infrastructure challenges you're running into right now. And I'll see you in the next video.